Please welcome to the stage TD Bank's Senior Vice President and Chief Analytics and AI Officer, Luke G., DeepSea's President and CEO, Steve Schillingford, JP Morgan AI Research's Multi-Agent Learning and Simulation Group's Sumitra Ganesh, PhD, Cognaze's founder and CEO, Vahe Andonians, and Evidence editor, Luke Gbedemah.
Terrific. It's good to be back. The time has not yet come where people can send their AI agents to the last mile of a conference and have them report back. We might be living in that world soon, and I actually think that this conversation could be a step on the way there. But thank you so much for coming to listen in to what I think really is the headline of this conference, the two panels that we've lined up towards the end of the day to tackle with, to grapple with a question that really is front of mind for the industry, for the media, I think for the public to an extent, and it's a topic that's really crashed to the fore recently, but has deep roots in the science, research, technology layers that banks and other organizations have been laying down for a while. So I hope we're going to be able to talk about what we talk about when we talk about agents. We're going to be able to level set a bit on how adoption of agents will actually work. Once we've started to disentangle what I think at the moment is quite an unsettled language. It puts me in mind of some of the big waves of technological change that have come in the past, and there was a time where people could have disagreed about what a website was. That sounds crazy now, but they could have and did. And I think there is a bit of disagreement about what an agent is. So I think we're going to try and disentangle that, as well as talking about the real value-adding capabilities that can come from human model, human-machine partnership. So we've got a great panel to do that with, and it would be awesome to start with you, Sumitra, not least because this is the core focus for you, one of 8, I believe, at JP, pushing forward the frontier of agent capabilities. But I understood when we talked before that this is not the start of the journey for you.
Yeah, so interestingly, I started working in this area when I joined the AI research group in early 2019. So right from the beginning of the AI research group being set up at JP Morgan, multi-agent systems was one of the core focus areas. We worked on building reinforcement learning-based agents, and we worked on building multi-agent simulation of markets and very large complex economic systems like the US mortgage market, for instance. So it's a very varied space, like you said, Luke, in terms of what is an agent. It's not something new. It's a concept that has been in the field of AI for decades, going back to the 80s and 90s. And interestingly, it's also there's a parallel concept in economics as well. But I do think that there has been a step change in the types of agents we can build and the power with the advent of LLMs and generative AI. So the field has been changed, definitely, with these new technologies coming in.
Yeah. Well, I'm the person on the stage who can look like an idiot, if convenient. So I'm going to ask the question, but hey, what is the difference between an agent, in your mind, and the current generation of LLMs that we are so used to hearing about and using now?
I think it's actually much more difficult to define what an LLM is than what an agent is. Agent, I think, is rather easy because it is a series of 3 things that you need to have. You need to have a sensory input, you need to have a reasoning engine, and you need to have tools to do some action. And then you give it a mission, like book a flight for me, and it gets the sensory input from websites, does some reasoning engine, and then has of course, the possibility to take, I don't know if this works now or not, possibility to take actions.
We can't get the agent to fix that. It's going to have to be done yourself. Is that all good?
Yeah.
Awesome.
So I think that that's the clear definition of it. much harder it is to understand what an LLM actually is, because that is something that is debated not only in science, but with lots of money. Is an LLM really intelligent? Is it not intelligent? Is it just a new computing architecture? Is it, is it just a non-deterministic platform? So it's very hard to define it right now. We don't know. But it is very exciting. And it gets very exciting because LLMs have one property, which is they can dream. And I mean it in exactly the way that I say it. An LLM is actually, I think, a dream machine. So you give it a task of, imagine you are a business analyst, imagine you are a rating analyst, imagine you are a trader, and then do some action. And the interesting thing is that it is very good at mimicking that. And now when you take several of those LLMs and have them communicate with each other, then you achieve something wonderful because they can challenge each other and they can find new paths, new ideas because of challenging each other. And that is, of course, the beautiful thing of it.
Yeah.
The difficulty, of course, is you need to channel this conversation somehow, because if you don't, it can very easily get out of this, what is called a policy zone, and then, do some weird stuff.
When you say policy zone, what do you mean?
Yeah, so a policy zone is you want, so generative AI is obviously not deterministic, so you don't have this, is it?
Yeah, I think it might be best to switch in this.
Okay.
Sorry.
So, yeah, no worries.
Is that better?
I have no idea. Yeah.
Thank you.
Perfect. So it's a non-deterministic platform, and you have to think different when you think about generative AI. There is not necessarily an answer is correct or wrong, but it is somewhere in a spectrum of being correct and wrong. And what we mean when we say policy zone is it in that spectrum where you would accept the answer or not?
Right.
And that's very important because the error that it makes is cumulative. So along the context window, when it once leaves or is close to the edge of the policy zone, it's very easy to jump out of it. Right? And that's what you need to challenge, to make sure that it stays where it does and finds an interesting solution to a problem.
Yeah. Steve, you put to me a very interesting kind of concept here when we were talking before the panel about how organizations are going to consume agents. And I thought, that in a way that makes sense to me. The realities of actually getting an agent as such into use in an organization. I wonder if you could talk a bit about the consumption model for agents, as it were.
Yeah, I think the framing is really important because I think we've heard a lot today about sort of deploying AI as an advisor or as a generator of ideas and dreams and sort of new concepts. And I think that's great, and there's really interesting use cases there. There's the other side of sort of AI, which is how can I, in essence, automate or give the mundane to the machine and let the humans who do their best, most creative work sort of, hovering above that, more capability. And I think that agents in that context are really doing the heavy lifting of a lot of, especially in financial services, of the deterministic work. The work in the back, front, middle to back office, affirming a trade, confirming a trade, clearing a settlement. The things where it's a 1 or a 0, there can be no hallucination. And I think what teams struggle with in terms of building those applications is it's not just all about the model. It's not just is it Llama or is it somebody else's model. It's really about the packaging of that training and inference task against what does ground truth and what does sort of right look like, and how do you codify that over time. And I think the combination of that package is what really can make an agent super powerful.
Yeah.
And imagine that for a number of different tasks, and you sort of concatenate it along like a train with boxcars, right? All of a sudden now you have a very complicated but very powerful sort of multi-agent train that can really, not only power the organization's efficiency and sort of resilience, but I think, I heard it earlier this morning, which I loved, which is how do we actually make money? How do we actually find, what I like to call competitive alpha, right? Like, differentiation amongst my peer set. And that's, I think, we all lived through the Gen AI bubble. I say bubble, but it was a hype curve, right? I think that now that that's subsided, we're really trying to use agents as the consumable package that we can deploy incrementally and get real value.
Well, I'd love to turn that over to you, Luke, in a city that is big enough for both of us. But the idea, I mean, you're coming at this from a bank perspective, kind of unique on this panel, but not in the room. It would be awesome to hear how you're looking at the balance of human model, human machine in that partnership. What do you see as the value creating aspects of this, what we term the kind of the arrival, the revolution around agents?
Yeah, sure. I mean, we operate in a very complex environment in TD. We've got a full suite of financial services that we offer to our customers. And so that brings with it a blessing and a curse. A blessing in that we can meet a bunch of financial needs, and a curse in that our agents and our colleagues need to understand a lot about a lot. And that's difficult. And in the scenario that Steve was mentioning in terms of a deterministic outcome, the beauty of that is you can hand the mundane activity to the agent, and then our skilled people can be involved in the more skilled pieces of work, whatever that may be. I think what's interesting is as you start to get into this and you start to work with compliance and risk functions, obviously we're heavily regulated and that can make things difficult. You start to get to a point of, we make an assumption which humans are doing this perfectly. And the reality is none of us are perfect. I'm very, very imperfect, as you can see. And as a result of that, we know that actually we need to baseline first. And as we baseline the human capability, that's what allows us to think about what could be possible with an agent, and therefore, can the agent be more consistent? The reality is the agent will be consistently consistent or consistently inconsistent, but it will be consistent. Unless, of course, we're getting into an LLM thing where actually it could be there could be some level of dreaming, but actually we can guardrail that.
Yeah.
Can I just, I think there's one thing is very important though, right? You're all from banking. You know how to extract information from a PDF, for example. Why would you even do it with an LLM? You're doing it with an LLM because it is not that easy, because that field is not always at the same position, that is not always written the same way, that even extracting the easiest thing, like a maturity date of a credit agreement, requires actually lots of reasoning. So saying that we don't need hallucination, I think, is just not going to work. Because if you don't have this hallucination, you wouldn't even need an LLM. Do it with RPA. Why are you here even? You can't solve it with RPA. You need actually hallucination because you need a tool that can find a new way of extracting it without you telling it to the tool, so that you can do the fun stuff, right? So I think that we have to be very careful how we define this hallucination. I think it's essential for the work that we wanted to do, and if we would not have that, it would not be able to find any solution to any problem. It would just be able to repeat exactly what you told it, right?
So are you saying, Vahe, that you see the problem-solving capability of an agent and the hallucination, or just the description you gave around dreaming, as more coupled than most people?
Yes, you cannot, well, I wouldn't say most people actually, because I think it's a very clear thing. You just think about this. If it is fully deterministic, then it can only repeat what it has ever seen before.
Right.
Okay? So that would be a Google search engine. If generative AI would not be able to hallucinate, any answer that it gives to you is something that it saw before at some point. Mm-hmm. That's not what you're experiencing. You're actually training it on a much smaller set and then letting it new data points to it, and you trust that it will find a solution to the problem. Mm.
But
please.
Please. I think it depends on what you define by hallucination, right? Just because it's sampling from some distribution over tokens doesn't mean it's hallucinating, right? Well, that's part of what it does. So I think we have to be a little bit more careful about what we define as a hallucination. Yeah, exactly. Right? So yes, it is producing patterns that it was never trained on before, right, but based on what is in its context window, right? So I think we typically think of hallucinations as places where it's not even just making a mistake. So for instance, agents might make a mistake in terms of picking the wrong field, even though it exists in its context. Hallucinations is when it starts making up entire concepts that simply don't exist. So it is not a reasonable kind of draw from your distribution. So anyway, a little bit off topic, but
But hallucination is defined, though, right? Hallucination is defined, right? It is an answer that is not represented in the training data. That's the definition of it. And per definition, if it always would answer that it is defined something in the distribution set, then you can just draw from that.
I will have to disagree with that definition.
Not because I'm sitting next to her, but I'm going to agree with Sumitra here 100%. I think where you sit matters here. Like hallucinations in a generative context, super interesting, can create new patterns and new connections and build new quote-unquote neurons. But in a setting where it has to be a 1 or a 0, especially in certain capital markets functions, you can't hallucinate. You can't hallucinate because you risk breaking a trade, you risk having a fine, you risk a lot of trust, you risk a lot of reputational damage if you get it wrong. And so I don't think you're wrong. I think it matters what you're talking about.
Yeah, but again, if it would be something where you can exactly say how to do it, okay? So simple question: can somebody tell me how to identify a table in a document? You cannot define that. It's not explicit knowledge. And you will need hallucination in the model to be able to find a table in a document.
So that's the first...
And as long as you don't have that part of it...
So that's the first step of extracting data, right? Absolutely, 100%. That's learning. You have software routers that will, essentially model route and figure out where the content is. But at the end of that process, if I'm affirming that trade, I sure as hell better not hallucinate.
Of course.
Right?
You're right. But it needs at the beginning.
Yeah.
The reasoning part.
That's
in the
the
middle.
content, right? That's the feeding of the model.
And without it wouldn't find the information, right?
Yeah.
So that's the point.
If I may, right, one of the big themes, I think, in this conversation should be the definition of entitlements, permissioning, creating the estate within which the agentic systems that we're talking about can operate and perform tasks. And I think that might be something good to turn to because that's really where the mitigation of the mistakes, hallucinations, etc., however we want to gloss that, that's really where they can do damage, where they exist outside of that permissioned environment. So I think a lot of organizations ought to be thinking about that. And I wanted, Steve, that's something you presumably have thoughts on, and maybe Luke as well.
It's so hard not to get down at the bare metal of these conversations around, okay, what does this mean? What's the meaning of that? And like sometimes you have to toggle up and say, what is the use case? We're all living in a regulated environment. And so there's always at some endpoint going to be a human in the loop that either ratifies a series of dispositions or on a disposition by disposition. They used to call it 4i, 8i checks, right? And that's what we're trying to sort of economize away. And I think that depending on where you are in that automation, where you're deploying LLMs or where you're deploying just straight machine learning curve fitting, the idea is you sort of know, I can't remember who said it today, but you should know where you're ending and then back into what the right agent structure is. And is it one agent? Is it multi-agent? Is it a bunch of tasks that form a use case? I think that's a really important consideration when you're deciding where to deploy.
Luke, Sumitra, perhaps you first. How do you see that challenge of, like Steve is saying, defining the end goal, the limits, and how do you think about that at TD, in fact?
Yeah, I think Steve made a point of, each one of the use cases that we're looking at are different. The data's different, highly regulated, exactly as you described. We have to be really, really sure. And we have to work out whether there is a save and a benefit to building a system like this, and then actually work out whether the human in the loop is qualified at the end to actually check the output. Those things all have to be true before we even put fingers to keyboard. And so the reality is that we have to look at our data really specifically. We have to make sure that the quality is strong. We have to make sure that it's labeled appropriately. And then we have to make sure that we build the routines with the human so that they check the output and they don't just take it and go. And we're really clinical on our side and where we're building in TD, which is there's a human in the loop in every step that we do right now. Now, we may get to a point in the future where that's not necessarily the case, but right now, I would say that's definitely where we are.
Yeah. I just want to say, if there are thoughts, observations, questions in the room, just raise your hand and we'll get some mics over. But if I could just turn it to you, Sumitra, quickly on that question of, are we really talking about moving to a place where there are no humans in the loop with agents? Or is that condition going to have to be maintained throughout the innovation development we're talking about here?
I think there are kind of two good reasons we have humans in the loop right now, and one not very good reason. One is, that most of these systems, and these are really systems around LLMs. LLMs are only one piece of it. Any agent-based system right now requires a goal, and most of the systems we are building are reactive. So essentially, humans are providing the goal. So the whole agent-based system gets fired off when some human comes and asks a question, sets a goal, might be even clarifies the goal. So I think that's a valid way, and that will probably continue. We will probably evolve to more proactive systems where agents come up with their own goals. But a lot of the systems we are building are places where humans are providing the goals. I think the second important ingredient is knowledge, and especially in a domain like finance, where when they're interacting with humans and trying to replace human workflows, a lot of these require a lot of domain knowledge and nuance. If you think about the types of credit analysis we do, if you think about the type of market analysis reports that we produce, etc., there is a huge amount of knowledge, and part of that is what humans are providing now. When we deploy these human in the loop, and they're providing this feedback and information. So what we are really focused on is how can we build agents that can actually learn from this on an ongoing basis to improve over time, because I don't think it's really practical to really sit down every person in the firm and say, okay, now let's get all the information that's in your head, because that's where some of this resides, into some structured form. So I think those are two good reasons. The third not very good reason is what Luke alluded to, is that there are of course regulatory reasons why you need it sometimes, but we don't have a lot of trust right now in these systems. So we have to slow walk it to release it to people who are experts, who can verify the output and go, okay, that looks fine, you can take that action, that's fine, that's fine. But that's kind of babysitting these agents at this point, but hopefully it's like training wheels. At some point we will be confident enough to let them go.
I like that idea. Yeah, babysit them in the short term. So do you see the kind of frequency of human intervention getting lower and lower and lower as the systems improve?
I think that is what we should be aiming.
Yeah.
That's our objective, yes.
Terrific. Do you want to tell us your thoughts?
Yeah, in the context of the previous conversation about hallucinations and the whole thing within financial institutions, could we say that all the training models must be non-deterministic to allow for inference and reasoning? But once you've finished training, the deployable model has to be deterministic?
The way I think about this is system one, system two thinking, where you the training and inference is really system one, right? It's really doing exactly what you described. And then I think system two depends on what is your use case? What is the goal of the agent or the process that you're trying to automate or solve for? I think when I talk about sort of above the line, below the line's all the back office, capital markets, sort of boring work, but super, super important to get right. Has to be deterministic, right? It's like, otherwise it's consent decrees, right? Above the line, if you're giving a wealth advisor some, tips and tricks or, alpha for a trader to go after, the penalty for getting that wrong is not as severe. And I think that's kind of the toggle in this, I'm just using system two as a label. Sure. That should be your heuristic for whether or not it's deterministic or not. If it's a 1 or 0 and that's got to be the answer, it's pretty obvious. And also the penalties matter.
I think, can I just add something here to it? Because I think there's a little bit of a confusion that the outcome needs to be deterministic. The process can't be deterministic. And if you want an AI model to be deterministic, it's very, very easy. Just don't use transformers. Go back to LSTM. Where are you using it? Because it didn't deliver the result that you wanted, right? And it was very deterministic because the same input would always give you the same output. In transformer, it doesn't because it has a context window. Now, if you remove this context window entirely, you end up with a very deterministic system, but you had that system already. And it didn't solve your issue.
Can you move from the LLM to a regular system after training?
that's the thing, right? You're absolutely right. That's the importance is exactly in this. You want the outcome to be deterministic, right? Because of, and it's not only because we are in a regulated industry, you also want it in non-regulated industries, okay? So you want the outcome to be deterministic, and you want it to pair with all other computing architecture that we have built, which are von Neumann architectures, and they are very deterministic. So you need to come through a non-deterministic process to a deterministic outcome. And yes, you can do that, and I think after this, there is another panel where people will probably show exactly tools and methods to achieve that point of view.
I think there's a question back here.
Speaking of more down-to-earth things, have you encountered or thought about the more pragmatic aspects of having multiple agents, like an agent description language? How would you find them? How would you maintain them? Agent ops, when the core foundation models underneath the agents get updated, what do you do as the data drifts and so on and so forth? So the real nuts and bolts of having agents in the wild 6 months later.
Yeah, I think this is a fantastic question. Where the rubber hits the road, we need to talk about permissioning, about interoperability. Do you have thoughts on that, Sumitra? Maybe we work this way. Go ahead.
No.
So we've actually built an in-house agent framework because precisely as you said, like if you're trying to build multi-agent systems, you need to have some framing around what is the definition of an agent, what are its capabilities, how does it actually communicate with other agents, and how do you kind of demarcate what is the role and responsibility of an agent and the corresponding entitlements and tools that you attach to the agent. So one thing I want to emphasize, just if I may make a point like from this discussion, I think it's very, very important to keep in mind that agents that we're building are not just LLMs, to your point also about determinism and non-determinism. So the LLM is just one piece of it. There is, there is a whole system and architecture around it. So if you think about any typical agent, one of the important pieces it has is memory, right? And with an LLM, you already get this short-term memory, so you can inject things into that working memory of the agent. But what we also find highly effective is to have longer-term memory, and in terms of what the agent can learn over time and persist. And so this whole notion of, if you want to get to your, when you talk about a deterministic outcome, for an agent, it is always taking actions in the context of all the information it has at that particular point in time, right? So there's a temporal aspect to this as well. So the way you get to better and better outcomes, more correct outcomes over time, is to make sure that you are actually injecting the right information and the agent is learning and persisting the right information over time. Sorry.
Please go on.
Yeah, I'll stop there, please.
I just wanted to sort of comment and underscore what Sumitra said. I can see a world 5 years from now where really agents proliferate. I'm not going to say it right. They're everywhere. And much like exchanges are today, where you have like exchanges that are dedicated with sort of certified agent stacks that work and interoperate, and an agent from JP Morgan can communicate with an agent from Goldman Sachs and actually, automate a particular process, with that outline that Sumitra talked about. Makes a huge difference, and I think that will catalyze adoption over time once we kind of define what the stack is. And to her point, which I really like, is it's a whole series of things. It's not just the LLM that matters in that stack.
Well, we're going to hear a lot more about that from some more rockstar speakers in a moment. So before we close, I'd just love to take that question from the back, and then we'll very quickly go round on what we might talk about a year from now when we talk about agents.
I love to talk in use cases. I come from banking and have brought AI workers and coworkers to Shopify brands. I'd love for you to tell me on the calendar when you think your killer use case of AI workers will be out there in production.
You've asked the question for me. Very nice. Go ahead.
I'd say about a year. Like we have pilots going out right now, and I think the first use cases are going to be fairly constrained in terms of scope, essentially to be able to guarantee that you get a very high level of performance and reliable performance from the agent-based system. So I think it's going to be about a year's journey to get to a point where some of these things are in production. But I think there's a huge amount of potential impact here. Luke and Steve already alluded to many use cases, but we are really seeing several use cases where you can cut down the amount of time it takes to do something from anything from several hours to several weeks to a matter of minutes. So it's really about, I think, at this point, really getting the performance to a place where it is reliable, consistent, and we are ready to let that kind of roll into production with those guarantees.
Just briefly, are you in agreement on that? Maybe Vahe, Steve, Luke, and then we'll finish.
Yes, of course. I mean, to be frank, one of these gentlemen is my client in the area of extracting financials out of balance sheet, income statement, and other documents. And I think we achieved some successes there. You can definitely go down from hours or 45 minutes to minutes and seconds sometimes even. And there are other use cases too in the area of processing documents. That is definitely an important use case.
Stephen, Luke.
I think the only thing I would add is I think it gets really interesting when you start to think about multiple agents and the potential compounding of errors if you get this wrong. And so we have to be really tight on every one of these, right? And understanding the interoperability between them is critical. And the moment as we move to production, to go back to the last question of, it sounds like our timings are probably pretty similar, actually, Sumitra, in terms of how we're thinking about this. But as we go to production, we've got to make sure that we are contained and we're clear about what we're trying to achieve. I think any of these that pop create a massive problem for us and for our customers. So we are tight on the benefit for the customers. If you're not clear about what you're getting back for this and the customer will win, then it's basically not worth doing. And I think that the reality is that I'm really excited about the opportunity, but I'm also realistic about what's possible in the time that we have. We're learning every time we deliver a use case, and the amount of learning that we get fuels the fire from our seniors. They want more. But the reality is this isn't cookie cutter. This is actually something that we have to look at very specifically for each one of the deployments.
Yeah, and I'm not a forecaster, but I agree with everything they said. I think there's going to be a moment in the next year where people come up with not to go full nerd, but like Kubernetes version of the agent stack that looks like something that everybody can get on board with and start deploying, to Luke's point, sort of consistent agent interoperability, and then start just demonstrating, okay, what use cases are going to work the best initially, and then learn and grow. I think that's got to happen in some way to really kind of standardize in some ways. Someone will do that.
Well, we might be about to see some of those someones, so we'll move on to the next panel. But thank you so much to each of you and to the audience for taking part.